Welcome back to chapter 13, first trig unit of the year. Our targets for today: I can find the reference angle of a given angle, and I can evaluate trig functions using reference angles for 30, 60, 90 degree angle triangles, 45, 45, 90 degree triangles, and also a little bit of the unit circle. Okay, reference angle relationships. This starts on page 868 in your book. A reference angle is three things: always an acute angle, it's always positive, and always an angle formed with the x-axis. Remember, acute angle is not a good-looking angle. It's an angle that's less than 90 degrees and greater than 0. Okay, so reference angle, you're going to see notation for it, possibly in your book. It's theta prime. That means reference. So when you see that, they're talking about a reference angle. Okay, so in quadrant 1, there is no reference angle. The angle is its own reference angle. So in quadrant 1, I didn't draw that, but in quadrant 1, theta equals theta prime. It's its own reference angle. Every other quadrant, that's not the case. In quadrant 2, okay? In quadrant 2, if I draw my angle in standard position, here's theta. My reference angle is the terminal side connected to the negative x-axis. How do we figure that out? Well, if we're in degrees, it's 180 degrees minus our main angle. Well, think about it. From 0 to the negative x-axis, that's 180. Cut out that, subtract that part, the actual angle, and you get your reference angle. Okay? Actually, let's make that degrees. We can hopefully make that stand out a little better here. And if you're in radians, well, in radians, 180 degrees is pi. So pi minus. Okay. In quadrant 3, so that's quadrant 2, let's break it up so you can see it. In quadrant 3, well, quadrant 3, your terminal side would be in the bottom left part. And this is our angle. Our reference angle is between the terminal side and the negative x-axis. Again, this is our reference angle. So the formula is similar, but there's a little bit of a flip involved. It's the main angle, theta, minus 180. And if we're dealing with radians, it's theta minus pi. Okay, so they can't be negative, so if you mess up and you get a negative value when you're in quadrant 2 or 3, then you probably use, or you get a value too big, you're using the wrong version of the formula. Okay, so think about where you're at. If you get an answer, it doesn't make sense. Quadrant 4, this is an angle that is spun out all the way into between the positive x-axis and negative y-axis. That's our theta. This is the only one where the reference angle is usually the positive x-axis on the terminal side. To find this one, the reference angle, it would be 360 minus our angle in degrees. And for radians, the equivalent of 360 is 2 pi minus theta. So those are the ways we're going to calculate reference angles. Make sure you have these pictures and formulas down as we move forward. I do not believe they're on the formula sheet. Okay, so have them in your notes so you can use them on your homework. Okay, so sketch the angle and then find its reference angle. Well, 210 degrees. We start here. We spin out, that's 90, 180. If we go all the way down here, that's 270. So 210 would be somewhere in here. Not to be exact. Here's our theta. So our reference angle is going to be this little piece right here. So this is 210. So what is our reference angle going to be? Well, we're in quadrant what? 1, 2, this is quadrant 3. So in quadrant 3, we look back, our formula is the angle minus 180. So our angle is 210. 210 minus 180. Well, that is 30 degrees. So our reference angle is 30 degrees. Down here, negative 260. Well, negative 260, we would go to the right, counterclockwise. So 90 negative, 180 negative, negative 270 would be almost to the positive y-axis. So here is our angle, theta. So our reference angle is going to be blue one here. It's going to be this one. So we'll get a little bump that it looks like. So here's our reference angle. Okay, theta prime. So what is that going to be? Well, for theta is negative 260. Negative 260, what I would do with that is I would find a reference angle, a coterminal angle with that, and I would add 360, which would give me 100 degrees. So this is the equivalent of a 100-degree angle. So if this is a 100-degree angle, we are still in quadrant 2. In quadrant 2, we'll take that angle, the 100-degree angle, that's going to be the one to use, and it's theta prime equals, or the reference angle equals 180 minus the original angle. Well, that we're not going to use negative 260. We have to use 100 in order to make this work. So our reference angle for this one is 80 degrees. Okay, so that's how we do it when the values are in degrees. When it's in radians, we can, probably the easiest way to do it is just convert it to degrees to see which quadrant it is, because 15 pi over 4 might be one that it's harder to see which quadrant it's in by itself. So we're going to take 15 pi over 4 and we're going to multiply it by 180 over pi. That's what you do to go from radians to degrees. When the pi's cancel out, we can do 4 goes into 180 45 times. So we're going to end up with 45 times 15, which is 675 degrees. Now that's too many times around, right? So we're going to subtract 360 like we did in the last one. That's going to be 315 degrees. 315 is somewhere in here. It's 315 degrees. We are in quadrant 4. So our reference angle is the terminal side and the positive x-axis. How are we going to find that? Well, that's going to be 360 minus 315, which is 45 degrees. Well, remember, they started in radians, so what do you think we're going to have to end up in? You guessed it, radians. So we want to get it back to radians. We take 45 and multiply it by pi over 180. And we get, when we reduce that in our calculator, pi over 4 radians. So we can do this with radians or degree measurements. Okay, so this is, we're going to reference what we kind of put on our unit circle the other day. This is a way to kind of remember which trig functions are positive or negative in each quadrant. The phrase, all students take calculus. Okay, so if we think of the first word is quadrant 1, the second word is quadrant 2, third is quadrant 3, and the fourth word is quadrant 4, then all students take calculus. All means all are positive, so in quadrant 1, all positive. Sine, cosine, tangent, and the reciprocals, or the inverses. 2, students. Well, what starts with the S? Well, sine starts with S. So in quadrant 2, It's sine and cosecant are the positive. Negative would be cosine, tangent, cotangent, and secant. Quadrant 3 is take. Tangent starts with take. So T, tangent in quadrant 3. Quadrant 3 is tangent and cotangent are positive. The negative ones are sine, cosine, and then of course cosecant and secant. Those are your negative values. Calculus. Cosine starts with the C. Remember, we're looking at the main three. So cosine and secant are your positive. Your negatives are going to be the rest. Tangent, or sines, so cotangent and cosecant. Those are going to be your negative version. So that's a way to kind of remember which function should be positive or negative in each quadrant. We're going to kind of use that information to calculate what the cosine of 150 is, along with reference angles. Okay? You can also look on the unit circle, and we can see how that lines up as well. Cosine of 150, find it exactly. Well, 150 degrees. That's going to be in quadrant 2. Okay? That's 150 degrees. So we don't have, we're going to do that exactly. We don't have a 150 degree special triangle. Okay? But what we do have is reference angles. So if we can find this reference angle right here, it's going to help us to determine, we can use that to determine any of the trig functions, in this case cosine of 150. So the reference angle in this one is going to be, we're in quadrant 2, so 180 minus 150, or 30 degrees. So we're going to use a 30, 60, 90 triangle. Remember, the side across from 30 degrees is 1. The side across from 60 is the square root of 3. And the side across the right angle is 2. So the cosine of... So, we're going to find the cosine of the reference angle. The cosine of 30 degrees, and we're going to use that to kind of determine what the cosine of 150 might be. So cosine is adjacent over hypotenuse. So our adjacent is the square root of 3, our hypotenuse is 2. That's what the cosine of 30 is. But we're going to use our all students take calculus and look in quadrant 2, only sine and cosecant are positive. Cosine, tangent, cotangent, and secant are all negative. So since we're in quad 2, the sine of 150 is negative. Excuse me, cosine of 150 is negative. And, so the cosine of 150 degrees is negative square root of 3 over 2. If we look at our unit circle, the cosine of 150 degrees, remember cosine is right on the unit circle. If we go to 150 degrees, 150 degrees, right here, cosine is the x-coordinate. What's it say? It says negative square root of 3 over 2. So unit circle, if it's cosine or sine, they might be directly on that. But we should always practice using our 30, 60, 90 degree angle triangles as well. Okay, so find the exact value of tangent of 225. Now this one is not directly on our unit circle. It's only cosine and sine, so we have to use the idea of reference angles for this one. 225, well that would be 180, 225 before we get to 270. So this is a 225 degree angle. So my reference angle here, what is that going to be? that would be, because we're in quadrant 3, it would be 225 minus 180. And 225 minus 180, well, that is 45 degrees. So we're going to use a 45-degree triangle to find our answer. So if you remember, a 45, 45, 90-degree triangle has side length 1, 1, square root of 2. So tangent, the definition of tangent, we're going to use this reference angle here. Tangent of 45 degrees. We're going to use this to help us find the tangent of 225. The tangent of 45 degrees, well, that's opposite over adjacent, or 1 over 1, which is 1. We're really interested in what the tangent of 225 is. The only question we have to know is it positive 1 or negative 1? Well, we're in quadrant 3. All students take calculus. So in quadrant 3, tangent is positive. So this remains, the tangent 225 is indeed the same as its reference angle in this case, and it's positive 1. Okay? Now if we go back to our unit circle, let's see if we can find that again. Our unit circle, oops, it's not there. Unit circle right here. 225, if we look at the two values, negative square root of 2 over 2 and negative square root of 2 over 2, remember sine over cosine is tangent. So y over x here, they are the same thing. When you divide them, you're going to get 1. So that's another way to do it on the unit circle as well. So that's our lesson for today. I think we addressed our targets. I think we found reference angles of a given angle, both in degrees and radians, and we evaluated trig functions using reference angles. It's very, if the reference angles happen to be 45, 30, or 60 degree angles, the reference angles are going to be very useful. Please have your notes for tomorrow, as I'll be checking them first thing in class. Have a good day.